In this video, I'll show you how you can solve a Z confidence interval for a population mean. Let's go ahead and read the problem. It says that the weight of a small package of potato chips is normally distributed with a standard deviation of 0.1 ounces. So that means that our sigma, our population standard deviation, is equal to 0.1 ounces. And it says, suppose a random sample of 4 bags has a sample mean of 1.54 ounces. What that means is we have n, our sample size, equal to 4, then a sample mean equal to 1.54 ounces. We want to calculate a 99% confidence interval for the true mean weight of chip bags. So we want to find an estimate for the population mean mu. The best guess for this, or our point estimate, will be x bar, and we want to calculate then a 99% CI, confidence interval or interval estimate. So the first step is to remember the formula for a confidence interval. We have our point estimate, x bar, plus or minus a z critical value, times the standard error, which is sigma over the square root of n. We have most of these values already written over here. However, we still need to know what z star is. Well, if we recall, there's a handy table in the notes that denotes each confidence level for the difference, or each z critical value for the different confidence levels, where z star for a 90% confidence interval is 1.645, z star for 95 is 1.96, and z star for 99 is 2.576. All right, so now we have everything we need to put into our formula. So x bar is 1.54. This is going to be our point estimate, our best guess for the population mean, plus or minus a z critical value of 2.576 times the standard error of 0.1 over the square root of 4. This is then equal to 1.54 plus or minus 2.576 times 0.05, which is equal to 1.54 plus or minus a margin of error of 0.1288. So again, the margin of error is always the critical value times the standard error. And then to get the confidence interval, we can add for the upper bound 1.54 plus 0.1288, which gives us a value of 1.67. And the lower bound, 1.54 minus 0.1288, is equal to 1.41. So our 99% confidence interval, which I like to write like this, is from 1.41 ounces to 1.67 ounces. And I've just rounded a little bit there.